So, hello. So before starting today's video, I would like to, uh, you know, have a special thanks and gratitude to my online viewers who have provided a lot of support and appreciation for my work. And I've had a few very interesting discussions in past. Some people actually connected with me over LinkedIn, and they actually said that the content has been useful, and that keeps me going because the good thing about it is that they don't have to do that, but they still came back to appreciate the work. And mostly I started this work for my love of teaching and the work that we do, but I must say that it feels good to be appreciated. And finally, the great deal of thanks and my utmost gratitude to the people who have actually subscribed my channel. And they have been fantastic because all the content is available on the YouTube. It's for free, so they don't actually need to do that. They don't need to subscribe or even like or anything, but they still did, and that shows that's appreciable, and it really humbles me a lot. So I would like to thank each one of you who have provided me appreciation or motivation in any sense. So thank you very much all. That being said, the topic for today is related to bandwidth parts. So this is a new thing that has happened into 5G. The concept was not there in GSM, it was not there in 3G, it was not there in LTE. So this is new and quite very interesting. So as we always do, we are going to start with the motivation behind this particular thing, and then we will look how it actually works. First we'll see on the top level how it is supposed to work, and then we'll go deep into it. We will deep dive a little bit and we will see what makes it work. So bandwidth parts, as the name suggests, it segments the bandwidth. The whole bandwidth is divided into parts. The question is now why and how. What do you know? Bandwidth in parts. Simple. So to define it in a boring official way, we can say that a bandwidth part is a contiguous set of RBs. Contiguous set of RBs. So basically, if this is the bandwidth, we cannot say that bandwidth part 1 is some part here and some part here and some part here. We cannot say that this is bandwidth part 1. That would be wrong. So the bandwidth has to divide in a contiguous manner. Okay. So in 5G, we call the whole of bandwidth as a set of CRBs. This whole bandwidth will be called a set of CRBs, or common resource blocks. This can be divided into a subset of resource blocks which will be called PRBs. So let's say this bandwidth is divided from here to here in a BWP. Let's say BWP IDX, and it will contain certain RBs, resource blocks. They will be called PRBs. So the contiguous set of RBs, which is a subset of CRBs, is called a bandwidth part in 5G. Why do we do that? Next question arises, what is the need of doing that? We were not doing that in LTE. Why do we suddenly want to make this differentiation? Why do we suddenly want to do that? So the purpose of bandwidth part is to enable low-end UEs. Basically, there may be some UEs which have high capability, very high capability related to different set of things, and there may be some UEs which do not have that much capability. So one such capability is affording a wideband operation. Okay. For example, if a cell has been deployed that has a heavy bandwidths have dramatically increased, uh, uh, you know, with regards to the advent of technology. They were not as big bandwidths deployed on a single cell in 3G as they were in 4G, and then now 5G bandwidths are getting larger, and then we have carrier aggregation and all. So all UAs may not be capable of doing operation on such a large part of bandwidth, because it is expensive in terms of baseband processing and power consumption. So to manage that, what we can do, we can initially we have to search blindly and everything, but once a UE gets latched onto a particular cell, it selects a cell and it latches onto that, does the registration and all, then we can tell the UE that okay, you don't need to monitor this bandwidth as a whole completely. You don't need to do that. All you have to do is just in this particular area do your operations. Your transmission is going to be in this particular area. So we provide a part of bandwidth for UE to monitor or for UE to transmit, and that is the concept of bandwidth parts. So what is the need? Need is to enable low-end UEs which cannot afford a wideband operation. So basically power consumption and baseband processing is being minimized here. Now few important points that you need to understand about the BWP. So BWP can, as you may know by now, as I said, monitoring as well as transmission. So BWP bandwidth part can be there in downlink and uplink as well. So first we will see a few things about DL BWPs. So in downlink, UE can be configured up to 4 BWPs. Okay, up to 4 BWPs. Can be less, but cannot be more. Okay, the bandwidth of each BWP, bandwidth of each and every BWP must be at least greater than or equal to SSB bandwidth. So SSB is a synchronization block that is used in 5G, and it requires a certain amount of resource blocks, and every bandwidth part must have enough bandwidth so that it can accommodate an SSB BW. It may be present there, it may not be present there, but beside the point whether it's present or not, even if it's not present, the bandwidth should be greater than or equal to that. Okay, important point, quite a very important point. Next one, only one BWP can be active at time, and that makes sense. That makes sense, right? Because this was our motivation. We didn't want to do a wider bandwidth operation, and that is why we are having the bandwidth parts. So this is another condition, only one bandwidth part can be active at a time. And what does that mean? That UE is not supposed to do what? To receive PDCCH or PDSCH or any kind of reference signals outside of active BWP. All these things UE will get only inside the BWP that is active. UE will not go outside the bounds. And one more very important one, every bandwidth part must have one UE specific search space. Every bandwidth part must have a UE specific search space. Okay, so basically the thing is that we will see different types of BWPs now. There are specific actually types of BWPs, and when we'll study, you will realize the importance of this point, that every UE must have at least one UE specific search space. Okay, so let us come to so this is downlink BWP. I'll give you a minute to let it sink in. So basically up to 4 BWPs we can configure. Each BWP must have a bandwidth greater than or equal to SSB bandwidth. Only one will be active at one point of time, and it is there UE will receive PTCCH, PTICH or any kind of reference signals, and every BWP must have a UE specific search space. Now about uplink. Now about uplink BWP, first point remains the same. So up to 4 BWP, this point is not basically relevant anymore. So only 4 BWPs, up to only 4 BWPs in uplink can be configured. Only one BWP will be active at a time, and that means what? Excuse me. Yeah, that means UE shall not transmit. This time it's not receive. UE is not supposed to transmit now outside of active BWP. Okay, UE is not supposed to transmit PUSCH or PUCCH or any kind of reference signal such as SRS etc. outside active BWP. And last thing, an important one, if UE has been configured with a supplementary uplink, that's another kind of uplink that is used to better the coverage at the cell corners. So if a UE has been configured with a supplementary uplink, this can have its own 4 BWPs itself. Okay, and again only one active. So that's about ULBWP. Okay, so basically we are parting the bandwidth, and we are giving one active part for uplink, one active part for downlink to the UE, and UE has to operate in that. Although we can configure 4, but UE will be operating in a single BWP. That's the gist of it in both uplink and downlink. Now we will go and study a little bit about first we'll study a little bit about some configuration and how does that work, and then we will study the bandwidth operation of bandwidth part switching. So BWP switching is kind of an important procedure, and it requires a keen logical mind also. So not just for implementation purpose, it's also a good topic if you are preparing for interviews. A lot of questions can come through this part. So let's have a look at the configuration. Once we are done with the configuration, through the configuration itself, we will be studying different types of BWPs also, and then we will be studying bandwidth part switching.